the title of this short-term course or faculty development program, or we can say that its talk is on the weight installation because of the deep learning or neural network. It's most important part to get the good output of performance, because the weight installation is combination of two words that is the called weight means the learnable parameter, and yesterday we already understand that in the time of hyperparameter and the parameters, that hyperparameter which are tuned by the users, or we can say that tuned by the ourselves, and then weight are the parameters that are the learned duration of the learning of the deep learning or machine learning or any kind of networks that is mimic the human brain. And initialize means to start an operations, where to this operation should start, and how to it's go to the performance at highest level within a short, or we can say that in convergence faster. So the basic idea in the presentation is that understand the importance of the weight initialization, and now we go for the some explore the strategies which will be benefited for the our techniques to enhance the performance in the convergence period is shorter, or we can say that in a shorter duration, or in expertise time saving for the get the good results. So evaluate the advantage as well as different kinds of methods, and on these methods to implement on the neural networks, and understand that how it is effective on the particular, we can say, the data driven models. So the all of you aware, I hope so, that the neural network, the in the right hand side, the portion of a neural network is basic architecture, which is developed by the McLeod in 1957, which is a mathematical model of human brain. And in this just that we can say that the inputs as well as the output weights matrix multiplication, and at the submission point, yeah, at this point the sum of the weight as well as the input multiplications, and then the one of the, like you can say that the activation function which is control the output to be how it is effective for the our data, or how to we can say that like it's kind of our tap of water, like it's controlled by the users to how it's passed through the water in from the flow of a tank or not. So similarly the weights parameters are the learnable, and it will be learned during the time of back propagations. Like first we go for the forward pass, and then go for backward pass. In the backward pass, certain kind of partial derivatives of we can say gradients and also are calculated, and on those basis these weights parameters are updated based on the error function of actual versus predicted at the output point. And the below diagram signifies that the similar kind of a network for the number of neurons. The first one is for a single neuron networks, and there it is a number of neurons with some kind of hidden layers, and after that also we can add on number of hidden layers, number of hidden neurons, and every hidden layer or every input to the neurons is connected through the weight. And on the basis of these weights, similar to the our neurons of our human minds, connected to the one human neuron to another with a certain kind of weight in the form of a mathematical or in the form of axon, we can say that in technical terms, to connecting these neurons. So these axon and these impact on the understanding or learning duration of a certain visualization by the users in the same as the human to replicate in the mathematics. So the now we start with the importance of weight initialization in the mathematical model of neural networks, which mimics the brain, is why we go for this, because initialization techniques, because there is a main thing is vanishing and exploding gradients. Vanishing means the weight, if you choose an weight parameter value is very low initial time, and it will reflect it in the certain number of iterations or certain number of learning time duration. It will be totally very low degrade, or we can say that it's totally eliminated or near about to reach to the zeros. So it means there is no importance of this learnable parameter. So that is called the vanishing gradient. And if you are choosing a very large like a large value of the weight value, and these value multiply, and the partial derivative means it's a chain rule to connect with one hidden layer to the another hidden layer. And that in that case, that is the multiply basically. In the if you are going for, not exactly we can claim that it's a multiplication, but it's a part of a chain rule. So that the case, the value of a large picking weight parameter is going to the very high weight value. So this will be go for the very high, or sometime in the PCs or our coding part, we visualize that it's like exploit, or we can say that it's out of memory, or a certain kind of a weight value reaches to the limit of bits or data types. So that is called exploding gradients. So these two main major cases avoiding, we go for the weight insulation techniques. And also the weight insulation techniques play a crucial role in the time of convergence, as I have explained you. If I will give you certain example of learning. If a person we taught a table of twos in 10 times, or first we visual gives a video or visuals that on the table of two or table of three, and then we taught that this is the learning of table two. So it is a different manner to get to be fastly learnable techniques. So that is called the slow convergence and faster convergence, because it's depend on the your initial training. So like kind of a weights initialization techniques is depend on where do you start or where do you begin, because the initialization is where to begin or operate. So that is the depend on the your this is also depend on your initial convergence rate, how fast you learn, how slow you learn. Because if you picking a very low value, it will be learn very slow. If you picking very high, it will be very high learn, but sometimes it's not reaches up to the output what we want. So that is the tuned good amount good control on the convergence with the help of weight initializations. And if you are choosing the same kind of weights like a zero, either one, or either any kind of a values of a constant, then it's will reflect a symmetric braking. Means if you are going forward to backward in the time of a learning, that is always give you a similar output in the time of every gradient value calculation. So it's symmetry breaking, and there is not such good amount giving a good output as we expected. So these are the major factors for the go for initialization of a weight parameter. And we understand with this figure that is giving below that one person who reaches, who wants to reach at top of the mount or top of the hills, how to its reach. If the person is starting initially with zero understanding or zero knowledge, we can say that. And then that time the poor weight insulation, similar to we connect with these figure visualization with the learning, because it's very easy to understand that why it's need or importance of a weight insulation. So if a person have no idea, it means start with the zero or start with a certain like constant value, that it means poor weight initialization, and it will reach its top of the mount with so speed. Person have no idea how to climb in the hills and how to survive for the longer durations, or how to walk, how to climb. Many factors are have no knowledge. That means that is a slower rate of learning, and reaches to the taken time reaches to the top of the hill. And if we understand certain kind of knowledge and acquire from the expertise who have already reaches, then understand the importance, understand the how to reach the climb, and map that the how to reach. So if we got the information learned before that climbing the top of the hill, then it will definitely converge a good rate, or we can say that it a very faster or very efficient manner to reaches to the top of the hill within a certain time, with the avoiding a certain collision and certain disturbances uh, overcome in the time of our journey. And that point of view, we explore strategies. We can go for the various expertise, like the person who reaches the top of the, like any kind of amount of city, any kind of amount of district, any kind of amount of state, any kind of like we can say that in the world. So every person have a different expertise and different reaches the top of the mountain. A person who asks with the expertise of one who reaches like for just trekking at the city, and you got the experience, that means and you want to climb at top of the uh, country. So it's maybe this experience reflect in your rate is maybe not very good. But if you take experience from the expertise of a world top of the hills climb person, and then after you climb at this country's top of the mount climb, then that will be more benefited, because the person who give you guidance or give her like transfer knowledge, that is more important than the a person who climb at a city level of hills. So that is the explore the various strategies, like kind of a various expert to take knowledge and then acquire, and on the basis of depend on these techniques, you should go for that. Which one is the best fitted for our journey. And then after the poor weight initializations, that is fast effect, sorry, the proper weight initializations means if you go for the proper guidance of that particular hills, a person who reaches already and one time or two times, and then after the effectiveness of the model, uh, how do we recognize that if the weight initialization is properly initialized, or we can say that the expert who have 10 times or 15 times climb a mount of the particular city, then that is the proper technique or proper knowledge we transfer from the expertise and reaches the top of the hill with the efficient manner. So now this is the story for the importance of weight utilization, and I will just giving the connections between the how to daily life journey of connecting through the your learning methods needs, why we initialize something part of a learnable parameters in our life, as well as in the method methods. So the now starts with the type of weight initializations, the various kind of initialization type techniques. So from the those techniques, I'm just giving an idea of a few of them, like zero initialization, that is means that in the and the constant initialization, and the another one is orthogonal, then identity, and the randomness with the certain kind of a distribution, either uniform, either non-uniform. The people are mostly using that normal distribution and uniform. On the based on these distribution, there is creating as various subtypes, like in the random uniform, random normal distribution, glow rate, normal distribution, glow rate, uniform distribution initialization, HE normal initialization, HE uniform distribution, and the Likun initialization, and Likun uniform, and Likun normal distributions. So now we initially start with the zero initializations, and in the zero initializations, like a formula, the weight matrix is set to the value of a constant with the zero, and that is the like initially start with the set of a zero. Then we pass through these weight matrix to the neurons, and then compute the output, and then calculate the in the backward learning durations, calculate the identical gradients. That is same for all neurons. It means that the networks behaves like act as a linear model. There is no learning, and it's stuck in the symmetric outputs. So learning stagnation is the fails to learn diverse feature. If we go for the various kind of different features techniques, features value to get the output, it fails to converge at a good output with the zero weight initialization. So the pros and cons as simplicity, because there is no need to put it any kind of a distribution, any kind of a picking value, just put it the zero for all the weight metrics. So it's easy to implementable and understandable for the beginners and the neural networks. The cons are that I'll give you just the learning. If you are go for the symmetry breaking, because of if your value are zero means the forward to backward it's all values are zero, and it's stuck up at the linearity because it's not giving a good output at all. And no learning because of the identical gradients have not accepting any kind of a certain diverse features. And the linear model that behaves like a linear and lacking in non-linear capabilities. If your function just if your output function is non-linear in the time, like parabolic or cubic shape, then it's not following that particular path of line. So it's just zero initialization is for the understanding or starting with the certain learning in the neural networks. And after the zero initialization, people are moving to the some value in place of zero, assign the some constant value like 0, 1, 2, 3.01 something. Like it's in, so in the formula w equal to c, and the c is the constant value, which is any of them. Like in the example 0.01, you can set up 1, 2, but still it's stuck up in this, like this simplicity of this initialized technique. It's predictable behavior in compared to the like a zero, but it's going to the vanishing gradients. Like it's goes when the learning of the networks, it's totally like if you are choosing a very low value like 0.001, that means it's after a certain amount of iteration it will goes to the near about to the zero, and it's eliminated on like similar kind of output to the zero initialization. That's why it's another disadvantage occur here with the symmetry breaking, like similar to the zero initialization techniques. And it's poor to perform because it's also not good if we are putting a constant value very low or either very high. If you are going for a very high, then it's exploiting gradients, and then it's like poor performance, and it goes up to the very high loss of the input to the output. Now we move to the like orthogonal weight initialization. So in orthogonal, like that is the two matrix multiplication with the transpose that is similar to the identity. So if your matrix and take your matrix weight matrix transpose whatever the you value fill out, like in place of weight matrix, you either choose any constant value or either choose either zero, either one, and then transpose it this matrix. And this output will be like your identity matrix reflecting, and it's have a own disadvantage before going to the that part. Initialize the orthogonal matrix with the help of orthonormal rows and columns, and apply singular value decomposition for the implementation point of view, and preserve the some activation norms like L1 norms, L2 norms, like maintaining the Euclidean norms. So in here is a mainly effective that Euclidean norms, and then prevent a gradient issue to like either vanishing, either exploding, and it's giving a good output performance in the kind of a certain predictable like forecasting networks are similar to the recurrent neural networks. You can say that RNN in the short form. So the concludes that it's gradient stable because it prevents some kind of like a major issue of the weight license. In the earlier we understand that the exploding as well as the gradient, uh, vanishing gradient and exploding gradients, and then the diverse representations of networks with the various diverse features, it will be understandable by these techniques. And the computational cost it's increases because we go for some kind of non-linear features as well as some complex features. That's why it increases the computational burden to the model. And then implementation complexity, it's require understanding implementation skills because what is the value for the metrics we chosen, because either one, either two, or any kind of. And now ability metrics, not just because of like similar to the if previously like identity metrics, it's a diagonal values are all are ones. and it's overworked process. Low intensity results in excessive work demand, and its efficient process high intensity leads to the significant work output, and high intensity efforts it yields to minimal work achievements, and inefficient process if you are go for low intensity and it's work a poor performance. So like identity is giving a good result or good outputs at the information flow for in the unidirectional, and then gradient stability is occurring this. It's will sometime it will go to the overfitting risk, because if you are learn that the overworked or over process the data, then that means give excessive work demand and it will efficient output, but it's we can say that it's overfitted to the actual output. So this is the main risk in that. Before going to the further techniques of initialization, we just understand that the two kind of distribution based initialization techniques have in the available in the certain like tools or on the available libraries of pythons and networks coding, like either normal or uniform. Normal distribution is totally like a bell shaped with the certain kind of available mean and standard deviation. On the basis of these mean and standard deviation to spread or decrease the shape of the bale, either you increase either you decrease as you want to distribution. But the uniform distribution have a upper bound with a lower bound and a certain kind of a likelihood function that will avoid that this bale shape to maybe you can achieve through the uniform distribution through bale shape of a normal distribution, but it's avoiding through the upper bound and lower bound based probability of a likelihood to certain kind of how much it's tracked to the weight initializations part. So the weight initialization techniques, we started with the like understanding the formula. Either you go for a small amount or a small amount of constant value. With the normal distribution, go for 0 to epsilon square, which is a constant value, and the uniform you go for the certain lower limit to upper limit. But in normal distribution, you started with the 0 to certain kind of a constant value. So in this, first choose a distribution for the random weight initialization, either normal, either uniform, and then set the defined parameter range of mean and standard deviation, and then initialize the weight based on the chosen distribution, and then after move to the evaluation of the gradient for exploding or vanishing it's occur or not. And then most of the time in the random it's totally it's favorable with the like weight matrix to avoid that these exploding and vanish grading issue, and modify that parameter to mitigate these issue based on the adjustment of our distributions, and set parameter of a mean and standard deviations. So the pros are the avoid the symmetry, which is occur in the zero and the constant, and it's speed up faster because of sometime hill climbing. If you are started for the top of the hills to track on the city, and randomly find a good path to reach at the top of the hill of city, and sometime you stuck up in the any not exactly top but stuck up in the below the top, or sometime it faces a certain kind of issue in the time of tracking. So that is the beauty of a randomness. Sometimes you got a good at faster output, sometimes you got bad in the certain time durations, but it's occur in the if you are if you are random distributed and random distributed graph is picking up a very high value, then it will goes to the issue of exploding, and it's picking up the small amount of a value of a constant, then it will reaches to the when it's and the another one is Xavier or Gloat. We can say that either both of name available on the some of the libraries like Xavier and the Gloret weight initializations. So these are the for mathematical formulations based on the uniform and normal. Like in the uniform, we are using the limit from the square root of a 6 to n in to n out. These are the depends on the in Xavier is based on the like how many your number of input units to the neurons to the how many number of the output units of the neurons. So totally it's belongs to the input and output. That means it's more efficient than the random and other. So it's a mathematical forms. The initialization, these initialization aims to variance of the activation roughly the same across the all layers, and preventing the signal from becoming too attenuated or amplified, like linear activation function behave like. So this one is more efficient in case of we understand that use case in linear layers, or in the activation function utilized with the weight initializes sigmoid or tan hyperbolic. It's giving a very good output results in compared to the previous one. And it's have two kind of initialization technique, uniform and normal. And the assumption is that it's used for always for the linear. It's giving good result if we assume that. And so the gradient control, it's mitigate the anything in exploding, and it's depend on a certain kind of activation suitability, like I told you sigmoid as well as the 10 hyperbolic activation functions. And it's complex implementations. It's because of it's a careful implement to avoid issue, because if you select a certain kind of very large inputs units and output units for the data point of view, then it will create a complex networks and complex initialization based enhance the computational cost of the training of a model. So this will be overcome by the some HE weight initialization technique, which is also depend on it's a normal distribution or it's uniform distribution. Both are depends only on the input in place of like output, but the previous one flow rate depends on the input neurons layer to the output neurons layer. And the beauty of this is the previous one is giving a good result on the linear like kind of a functions, or on the basis of activation function which is used like sigmoid and tan hyperbolic. But this is giving a good output result, identify the good result with the ReLU activation function, which is picking up a non-linearity of the data, and then calculate the certain kind of variance and draws a weight with based on the normal distribution, and apply these weight to evaluate the neurons activity and adjust some kind of a certain kind of a variance to get good output. So that in this the issue is that it's not suitable for sigmoid. It's suitable for the ReLU. It's efficient with the ReLU activation function. It's giving a certain kind of issue. You can test it in the coding point of view to test that, apply a certain kind of activation function sigmoid and check that the output is the occurring in some certain kind of issues. It's require careful tuning, but it's prevent the vanishing gradient issue. And the also the good choice of initialization technique is Luke one, which is similar to the Achi normalization, previous one. And but the case of output is like last previous one is depends on the input, like we are visualize that it's a part of actually 2 divided by something range of any number of inputs, and in place of just going for the certain values, and on the basis of these certain values it's a good choice of ReLU, as well as it's compatible with ReLU, and the variance depends on an input neurons. So it's better perform with the normal distribution. You can also test it with the uniform distribution. And that the finally the part of that learning is that we understand the in the starting one, the example of hill climbing top of the mount. So how do we take that is the not the part of this. kind of types of like initialization. But in this, we just like acquire this data information kind of like the person who already reaches top of the mount and reaches top of the hills of a world as well as countries, and we just discusses and take the information and get the good amount of like knowledge acquired, and then these expertise you implemented in your life, like to reach the city's top of the mount. This means the knowledge has been transferred by the one person to the youth. Is that already the weight parameter or already learning is done by that user to forward it to the youth, and then these information understandable part you forwarded to the next one. So this is the part of like already acquired knowledge used in the current one applications or current one problem issue, and then these these are called the pre-trained models learning, or sometimes in technical terms called the transfer learning knowledge. So in the transfer learning of neural networks or networks, that means that you are acquiring the previously trained model on a large data set like CNN and ResNet, and then VGG16, VGG90, various kind of networks that are already trained on a large amount of image data set. And these data set information, trained information, means the learnable parameter information in form of like weights is freezes and directly forward to the current one. And we are using on our different problem because with the first, the previous one is trained on a large data set, but not in the current situation. But the previous experience has been incorporated in the present one. So, so this one is called the transfer learning, and we use the weight initialization from the pre-trained model and extracted the learned weights, retrieve the weights from the previous network, and initialize the new model, and then train the new model with the certain kind of a tuning, and improve the performance, achieve the better performance with the faster training because of already gained or already obstacles that will occur by the person who has already traveled the path. Is have experience how to you avoid obstacles and how to you reach the top of the mount and the hill. That is the very good way to learn. So sometimes in our family or in the our daily research, like in the earlier yesterday hyperparameter tuning, I already giving you an example that the people who are working in the research domain, that they explore more, because if the control or tuner is not available in the form of like a supervisor or in form of like our guide, that control or to avoid that you are not going to the more explore in place of giving going to the certain kind of exploit and then reaches to the pin or aim of the your PhD or your aim of the research. So that is the part of learned by the supervisor with the certain number of or certain couple of years experience has been transferred to our students or our researchers, to that you go, so you should follow this path, and then you will reaches to the research target output within a duration of a certain amount. If you are not following that path, definitely some researchers go take more time, some researchers take very less time. So the optimal tuning by the supervisor or by the guide playing a good role, like kind of the pre-trained weight initialization. If we acquire a good amount of knowledge from the previous expertise and then transfer to the current one, that will reflect in our learning. So that is a not exactly part of a weight insulation, but it's a kind of a part that already trained weights has been transferred. So the use cases of all the techniques, now we understand the one by one. In the previous one, we are combining like normal as well as uniform distributed in the combined manner. The first one is the zero initialization, that is the fixed value of all weight matrix with the zero, and it's not suitable for most of the scenarios due to symmetry issue. So it's stuck up in the like symmetry issue. Like I already explained you, like it's giving the same gradient value in the forward as well as the backward, and similar to the zero initialization, not generally recommended because one initialization like means you just replace in place of zero to like one, or also you can say that it's up to the constant value. We're just replacing a one value, and it's stuck up in the similar manner like symmetry issue as well as the vanishing gradient as well as the spreading gradient. So this orthogonal, that means the weight parameters are the matrix of weight with the transpose of matrix is similar equal to the identity matrix, which is generally used for maintain the our problem is orthogonal norms formality. Then we definitely choose for the orthogonal initialization, and the identity initialization is giving a good result or a good amount of output benefits on the basis of like RNN networks. So keep the identity, and then after random initializations with the normal distribution, that is versatile or generally used to introduce variability or complex features. So because of okay, it's sometimes it reaches to the very faster convergence, sometimes stuck up in the initial phase. So it's taking a time to sometimes it's like if you choose a random value is very low, then it's go for the vanishing, and it's picking up very high, then it's go for the exploding. So so better to avoid these are part. So go for the uniform as well as it's giving good for the general use, but it's also certain limitations of random. It's best it other if you want to go for the network that is shallow networks. So its random distribution is giving a good output results. And then after glow rate, or we can say that another name is Xavier, it's picking up with the giving a good output result with the certain kind of activation function, and it's giving if it's we are not using these activation function, that means it's sometimes stuck up in the issue of vanishing and spreading gradients. So the ideal for the it's we can say visualize the ideal for sigmoid as well as the tan hyperbolic, and for the checking of the these issues, and the achieve normal initialization best for the ReLU activation function for the achieve, and it's suitable for the ReLU leaky ReLU, and the like variation in the ReLU kind of activation function, because it's prevent to avoid these exploding and the vanishing gradient issue with the help of these activation function. Otherwise these initialization technique have facing some issue of those exploding and vanishing gradient issue. And the last one, the two are the Lee-Kun and uniform distributions. These are the design for the value activation function, which is like a scaled exponential linear unit, which is controlled through the certain kind of the two parameters value of certain kind of, we can say that the regularization factors, based on regularization factors, and then control with the help of these factors. So the completely these are the techniques which are initialized to weight, and these techniques based on understanding we go for the our network's convergence speed as well as avoiding some kind of our data problem is facing the issue of exploding and vanishing. So various factors to in the time of the data we pre-process. If we pre-process, we are not pre-process, but is still using certain kind of direct data sets. Sometimes then go for the initialization. So there is a various part of initialization, which is I am giving idea, and these all libraries are available in the available networks of available libraries. So now we conclude that the techniques as well as the part of the today's lectures on the weight initialization techniques. So first we understand how about the weight initialization techniques and how it's effective with which kind of activation function and what are the issues faced by the or we can say the cons of that particular initialization technique, and understand the strength and weaknesses, means the pros and cons of the methods, and like the guidelines established by the selectable suitable strategies. Like if you are going for the like coding point of view, there is available part on the code that which kind of method is you want to, which kind of techniques of initialization used in these methods. You just type it in the name of like HE norm, HE uniform, like other in place of Lipone, in place of Gloriette, in place of random. So you can test it with the all kind of techniques with the data problems, and go for the more refinement, and we find that the experiments to fine tune the initialization for specific tasks. Like if your problem is like I was giving a good example of initialization part of with the hill climb. So it's a very good example to understand that how to we start, how to we end up, and in between journey of reaching that part with a certain kind of knowledge, a certain kind of expertise to acquire these initialization part for you, because you are the newer one. So this one is the taken experience is helping to avoid those obstacles and disturbances in the path of reaching to the top of hills. And finally, we achieve the optimal performance with the best possible initialization techniques to get a good amount of results. Also, you can check that the every initialization techniques with the suitable activation functions. Various activation functions are there. It's totally depend on your output of data, which kind of your data, like.
Hello.
Yeah, yeah, ma'am. Hello.
Yes, Naveen, I
It's
think there is a power cut.
yes, yes. It's okay, ma'am. I have already connected the IP on network. So,
Okay,
okay,
okay.
I will share again.
So, participants, Naveen is joining in 2 minutes. Am I audible? Hello, am I audible? Yeah, so I think he's joined. So we'll be starting
Yeah,
in a
yeah,
minute.
ma'am.
Yeah, yeah.
Yeah, the finally we conclude that the whole story of the today's presentations. Now you can ask any queries, so I can resolve the concern regarding the initialization techniques. I'm more happy if you have any kind of queries. If anyone have any queries, please raise your either you can type it in the chat box.
Any questions?
Any queries from the participants? So it's most important part to learn that the initialization is how it's effective in the data-driven models.
Sure.
I think there are no queries. Okay, Lena has raised hand. Lena, do you have any query? No. Anybody else having query? Any doubt? Okay, I think there are no questions. Naveen, I would like to thank you for your insightful and engaging presentation. Your expertise has really added tremendous value to this entire workshop. And on behalf of the participants, on behalf of the organizing committee, EICT Academy, I really appreciate the time and effort you took to share your knowledge with us today and in yesterday's session. It was both informative and inspiring. With this, we really thank you, Naveen, for joining us.
Thank you so much, ma'am, giving me this an opportunity. Again, I am very happy to share my expertise and knowledge among the participant as well as the joint persons who are the panelists, as well as they are highly actively listen the yesterday as well as the today's sessions. So
Yes.
it's great of honor to me to present my expertise or my knowledge. And not now I am the full of expert, but I am in the era of learning.
Thank
Yes.
you.
Thank you
Thank you,
so much.
Naveen. Thank you.
Okay, thank you so much, ma'am.
Thank you. So, participants, we would be resuming and moving on to the next session at 12:15. So, at 12:15, we have the session on transformers and attention deep dive by Professor Marko Robnik from University of Ljubljana, Slovenia. Uh, I request all of you to join at 12:15 again for the next session. Meanwhile, you can fill the feedback form and take a short break before the next session. So we will resume at 12:15.